Hello, this is Chris, ZL1CVD. Well, today we're going to talk about an aircraft transceiver that I've managed to get going. So we'll just show you. Over here we've got a analyzer, and this here is the transceiver itself. Patch leads to a connector block, audio out to the handset. From there there's power coming through from this battery pack here via a volt and current meter through to the connector block, and the big cable, the red cable at the back, goes to the control head for this transceiver. This is a Selex or RT a VHF airborne seat. It's an RT-651, and this particular transceiver I purchased off eBay some time ago from eBay UK, and these were fitted to the Tornado G3 and I believe the G4. I've had issues getting this going because I didn't have any wiring information, so I've had to work most of it out. This is the actual transceiver unit here, and with no wiring information it was a bit of a challenge. So we can see the number here, RT-651/NT. The T is for tornado. After some communication with someone on the internet who got in touch with me, it seems that what happened with the tornadoes, they have a standard wiring loom, bit like a car, but of course it's an aircraft. And as they upgrade the transceivers and all that, rather than rewiring it all in, they try to use as much of the wiring loom as possible. So like most aircraft products, this uses the military circular type connectors, as you can see there, many wires. So that was a little bit of an issue, trying to work out what goes where. But I guess I really managed to work out a bit more from the Sea King online. I found a Sea King manual. The Sea King is a helicopter in the British Navy, and there was a circuit diagram for how they connected up the Sea King. So that gave me, I learnt how to connect the main audio wires through. And this is only just rough wiring here at the moment. It should have shielded cable for the audio, which I haven't used. And it's such a short run, it should also have shielded cable for the data. It uses a serial RS-485. It's just not quite like a RS-232, but I guess the serial data side of it, as far as the data format goes, you know, data bits, stop bits, parity bits, they're almost the same. But it's the electrical interface which is quite different. So look that up. It's a 485, RS-485. So we'll just turn it on, have a look. And we can hear the double beeping going on there. And we can see that the frequency's illuminated. Now the radio itself has got, we'll have a look at the specs over here. We'll go to the next one. Oh no, we don't want that, we want the next page. So if we have a look at the page here, we can see the frequency that it does. Blow that up just a little bit. So it does the VHF FM band, which is 30 to 88, which is a common military band that they use, and the old manpacks, the old PRC 77s were a 30 to 88 frequency band. It does the VHF air band. This 108 to 116 is used for navigation, so in this transceiver only receive is enabled if you dial that frequency in. It does the VHF AM air band, which is from 116 to 156 megahertz. It also does the UHF FM band, which is 156 to 174. This is actually the marine band. And this transceiver does the UHF FM or AM band from 225 to 400. This particular model does not do the 400 to 470, which is a shame. So it covers two of my amateur radio bands, which is the 6 meter band in between 30 and 88 in FM, and it will do the 2 meter AM between on 140. Okay, pops out 10 watts AM and 15 watts FM. Here we are. There's the details. Now these transceivers have what we call a guard receiver in them, and that's an emergency receiver where, or guard frequency it's often termed on controls that you might see on military gear, and on this it has that as well, and that's what these GU and GV are. So guard for UHF and guard for the VHF band, and then we have manual preset and load. And the bottom control here, we can have it off, which you've seen. We can have it transmit receive, so for normal transmit receive, or transmit receive plus guard. So that means an additional receiver is activated inside this transceiver, and that's locked onto the emergency frequencies. I think it's 243 megahertz, and there is another guard frequency as well, but anyway, won't worry too much about that. When we start it up, you can hear it doing the beep beep. That acknowledges that it's going. It's quite a hungry little beast. On receive, we're drawing 1.4 amps, and if I key the transmitter, we're drawing 5.07 amps. So at the moment I'm transmitting on the amateur radio band, but I'm not actually on air. I'm going through the cable which controls the transceiver via a serial interface, out the coax here to an SWR meter, which doesn't like UHF VHF, it's an HF SWR meter, but it's what I had handy. We go then down into this is the RF lead, it goes down to our analyzer here via a 20 dB 100 watt pad. This is a Rohde & Schwarz CMU 200. Well, this one's equivalent to a CMU 200. It's called the CRTU-RU. This is the one that they had in the factories for aligning cell phones and setting up cell phones in the factories. I liked it because it also has the CRT-RU has the built-in splitter on the front panel, so you can use that for all these other things. Plus it also has USB on the front panel, so I can plug my keyboard and mouse in there if I'm using it. But it essentially does everything that CMU 200 does. Alright, so if we key the transmitter, we'll be able to see our carrier, and we can see that we're putting out about 15 watts there, because we're putting out FM at the moment. And the noise that you can hear in the background of a little Yaesu that's picking up the signal on 145.350. It's actually FM at the moment. The radio does have the capabilities to select between FM and AM, but interesting enough, this controller is a controller for on the Tornado. I'm not sure whether they've got two seats. They've got a pilot seat, and sitting behind the pilot is either the co-pilot or navigator. I think it could be navigator. Anyway, this is the control from the co-pilot navigator position. It doesn't have, the pilot's control has a switch here for AM FM. It also has a high, low and medium power switch over here, and one other switch. I can't remember what that was all about. Main or remote, I think it was. Now, I couldn't get this going. I couldn't figure out how to get this going until Paul contacted me, and I'm not sure of his call sign, but he contacted me on QRZ and said, Chris, I think he was playing around with there is a on eBay there is a Tornado. It's a frequency display only. It's not a control unit like this, and Paul was playing around with that, trying to get that going, and he found that by grounding one of the wires he could make it go live, and so that gave me the idea of, okay, we'll have a look at the wires that I traced out, and I'll try grounding them. I had tried grounding them, but I tried grounding them with a 10k resistor because I didn't want to blow anything up in the controller. But of course that wasn't enough ground level for it to actually activate it. Once I grounded it, the 480, the serial data lines, 485 data lines, came to life, and I could communicate with the transceiver. So the interesting thing is everything that the AM, FM, the frequency, the squelch, everything is via this RS 485, this 485 serial data. I'll show you here. I'll turn squelch on. You can hear the handset here. Then I'm turning squelch off. And that's serial data that's being sent along to the transceiver to turn the squelch off and on. So my next project is I have a little handy dandy dongle here, and this is a you can see here it's a USB to RS485 adapter, and it's got the A, B and the ground. G and E is ground. I won't be using the 5 volts, so I'll just use A, B and ground. And my serial data lines are these two here. So what I plan to do is with RS485, unlike RS232, I can just tap as many serial devices, daisy chain them off here. Well, not daisy chain them, star. I suppose it is a star, I'm not sure. Long time since I did networking, but anyway, I'll connect this to here, connect the ground and connect the serial data lines, hook it up to my PC which runs Linux, and we'll hopefully engage a bit of chat GPT and see if we can decode the what's happening. If I can capture a bit of serial data, chat GPT tells me that that it can work out what's happening. So so long as it's got quite a few frames to compare, we should be able to either decode the data or whatever. But the good thing is this doesn't have, well, the bad thing is this doesn't have AM FM on it, or the high-low, so it's always in high power because it's the slave unit. And I guess the high-low would be set by the master unit, I'm not sure about that. But because it doesn't have the AM FM, what I can do is certain frequencies are locked onto AM and the rest of it's FM. So I'll use that knowledge to determine, once in the serial data I work out what the bits are that's sending frequency, I should be able to work out what bits are sending AM FM. But anyway, that's a future video, I guess. So this is the transceiver, and the connectors on the transceiver, well, there's quite a few. There's they're all TNC screw type connectors, which is like a BNC but with a screw. But you can see you've got Homer, Guard and DF. Now these transceivers, well, the military supports this direction finding system, which is I don't know if you see on here the tone setting here. If I click it to tone, you can hear that. So it transmits a tone, and that's I believe so that the tower can lock onto you or something like that. But there's also a radio direction finder attached to them, and I believe that's how the antenna works. I really don't know a lot about it. This is why I love playing with this stuff. You get to learn new things. So anyway, that was just a bit of a thing to see. Yeah, so this is the control units. Now these control units are still on eBay, the CP9000/T. On eBay UK you can buy them, but no, the transceivers you can't buy anymore. I was lucky enough to get 2 of those, and this is going back about maybe 4 or 5 years ago. Anyway, I'm pretty chuffed. It's all working. And I was going to show you how I can receive. So on our analyzer, we're in the generator screen here. So we're putting out 50 millivolts, and our dBm, minus 50 dBm, and our frequency is 145.350. My modulation is actually AM. Okay, so anyway, we will go. So we're generating AM, and you can hear it in the background, hopefully. Yeah, so it's definitely, the radio's on AM at the moment, because that's what it's picking up. So yeah, so it's receiving. You can hear that tone there. Just turn that off. Okay, so what else do I need to, what else was I going to say? Oh, audio levels. These radios put out about 0 dBm, or 0 dB into 600 ohms. So that's why I've actually used this military handset. I mean, it's 150, but it's better than an 8 ohm speaker, I guess. And I haven't really got the microphone side of things hooked up because I think it also requires that. So we would need to run this all through something like, where I've got it, I've got it down here. This thing here, this is what I commonly have in the in helicopters and so forth for switching between the different transceivers, and it also has an audio amp into it, so you can feed microphone input. Oh, hello Dash, what are you doing? Yeah, so I will be keen to add this to into the system and get it all up and running, and I want to have it with this UHF, this really nice Roden Schwartz here. So yeah, so that's what I've been doing, and that's mucking around. Alright, thank you for watching, and season's greetings to you all. Cheers.